Hello, welcome back to another video. In this video, composite functions, again. But in particular, we're going to speak about the domain of composite functions. What about the domain of composite functions? We're going to be using these two functions to make up this composite function over here. And we're going to use this composite function to analyze and work through its domain to find out some key ideas. Now, inputs have to do with the domain of a function. When we think of domain, we think of possible inputs or the inputs of a function. And when we think of range, we think of outputs. Outputs have to do with the range of the function. Now, with all this in mind, let's consider this composite function again, because we're going to be using it to understand the domain of a composite function. Now, I'm going to say something. The domain of f is the range of g. Here's why. Again, the domain of f is the range of g. We have this function f over here. We're plugging in g. We're plugging in values of g. We're plugging in values of g, which means we're plugging in the outputs of g. We're plugging in outputs in the place of inputs. And outputs have to do with the range. So the inputs to f are the outputs of g. And those outputs correspond to the range of g. So we're plugging in sort of the values of the range of g. And now, since we're plugging that in, they have become inputs. Now let's call this composite function some function h of x that's defined by this composite function. Okay, so we have our composite function over here, h of x, defined by a f of g of x, which is equal to this. Let's write out quickly what each individual function represents. F of x is equal to 1 over x, g of x is equal to x minus 4. All right, to move on, let's consider the value x is equal to 4. Okay, what are we going to do with this value? Well, the first thing we can notice is that it is in the domain of g. 4 belongs to domain of g. It's a possible input to g, which makes it part of the domain of g by definition. Because we know g of x is equal to x minus 4, and if we plug in 4, we get 4 minus 4, which gives us 0, which is a real number, which is a reasonable output, which means it works. So 4 is in the domain of g. Good. Step 1, we passed. And let's go back to our composite function, how it has been defined, how it was defined. F of g of x is equal to 1 over x minus 4. If x is equal to 4 is part of the domain of this function inside here, g. Does it mean it's part of the domain of this whole composite function? And we know the domain of this whole composite function is the outputs of g. The range is now the domain of f. That's a good general statement to keep in mind. But again, does having a point in the domain of this function g mean that it's in the domain of the whole composite function? The answer is no. And that's going to take us to a conclusion and sort of a rule. Why is that? Well, notice here, g of 4 is equal to 0, as we've just found. F of g, let's plug in 4, is equal to f of 0 from above here, which we found. And we know f of 0 is equal to, because f of x is 1 over x, 1 over 0, which is undefined. It doesn't work. And again, instead of going step by step, let's go straight to using the composite function. 1 over x minus 4. Let's plug in 4. 1 over 4 minus 4 is equal to 1 over 0. Again, we see, obviously, doesn't work. It's undefined. So what we have to do here is exclude x is equal to 4 from the domain of the composite function. X is equal to 4 for g of x works. X is equal to 4 for the composite function? No. What does this all tell us? Well, it tells us that the domain of the composite function, f of g of x, which is equal to h of x, as we've named it, it consists of the numbers, or the values x, in the domain of g of x, which makes g of x in the domain of f of the composite function h of x, or in the domain of f, because we're plugging in g of x here. Again, what that's telling us is that, say, again, we're using 4. We have the number of x is equal to 4. It's in the domain of g of x. But does it make it in the domain of the composite function f of g of x? No, because it gives us 0, and when we plugged in 0, we found that it's undefined. So we exclude this value x is equal to 4, because it's in the domain of g of x, but for this value x is equal to 4, g of x is not in the domain of f. Great. Thank you for watching. I'll see you in the next one. My email is below. Send me anything math related. Goodbye.